Good morning, students. The next topic in physics is thermal properties of matter and thermodynamics. We are discussing thermodynamics actually a separate topic, but I am mixing with this thermal properties of matter only. In this thermal properties of matter, that means expansion or contraction of the solids, liquids, gases we study. But first I will discuss solids, gases, then we go for the liquids. Liquids is not much covered except for the concept questions. Next, linear expansion coefficient. Solids have the three type of expansion coefficient called the linear, areal and volume expansion coefficient. That means if you take a solid, if you heat it, length changes, breadth changes, height also changes. That means thickness changes. Because changing length and breadth, the area changes. Because changing length and breadth and height, volume changes. Because the length change is also present. The length changes is measured in terms of the linear expansion coefficient. That is a constant for the given solids. Alpha is nothing but equal to changing length by initial length per 1 degree centigrade is the definition we take. Delta changing length by initial length per 1 degree centigrade. Alpha depends only on the nature of the material, depending on the molecular force of attraction or interatomic attractions or molecular force of attraction to given materials related to the electron bonds or electron configurations. So for the given metal, alpha is constant. Amorphous solids, alpha is constant in all directions, but in the case of the crystalline solids, alpha is different along the x-axis, y-axis and z-axis. And if you alpha is for the linear, but area also changing, therefore we will call it the areal expansion coefficient. Volume changing, volume expansion coefficient. So we have the alpha and areal expansion coefficient is beta and volume coefficient is gamma. Instead of this beta, it may be mentioned as alpha area A, and volume coefficient means alpha V also may be mentioned, simply alpha linear means lengthwise changes, areal changes and volume changes can be mentioned. But I am taking it as old symbols, alpha, beta and gamma. Beta is related to the area changes, that means beta is equals to change in area delta A by A into change in temperature. Gamma means change in volume by initial volume into change in temperature. The relation between alpha, beta, gamma is 1:2 2:3. That means beta is approximately equal to 2 alpha and gamma is approximately equal to 3 alpha, which is equals to alpha plus beta also we can take. But if you take the crystals, the gamma is equals to alpha plus 3 alpha means alpha plus alpha plus alpha. For the crystals, we have to take gamma is equals to alpha x plus alpha y plus alpha z. Some of the three quantities you have to take, because xyz along the xyz axis, the expansion is not uniform for the crystals. In this question number 1, linear expansion coefficient alpha is given, expressed in terms of centigrade, and they ask you to convert into Fahrenheit scale. Conversion of the centigrade to Fahrenheit scales, centigrade conversion you have to do the reading. If you are converting the temperature, single temperature value reading, C by 100 equal to F minus 32 by 180 Fahrenheit degrees, centigrade degree, and this is the Kelvin scale. Kelvin, don't put a degree please, it is only theoretical scale and the standard scale. Kelvin scale do not have the negative values. Fahrenheit, centigrade can have the negative values. Again, Romer scale also there, but not important for us. This Kelvin scale, centigrade scale to Kelvins. If you convert the centigrade Fahrenheit Kelvin conversion is this formula we have to take, and the temperature difference if you convert this only you have to equate the denominator values. 100 degrees centigrade is equal to 100 degrees Fahrenheit equal to 100 degrees Kelvins. That means you will get a conversion 1 degree centigrade is equals to 1 Kelvins. Temperature difference it is. Temperature difference centigrade Kelvin scale, there is no change in temperature. 2 degree centigrade change is nothing but equal to delta T, it is equals to 2 Kelvin scale Kelvin degrees centigrade. Kelvin temperature change. Kelvin temperature we mentioned as capital T and centigrade generally we mentioned as a small t. But temperature difference, small t, capital T difference is same. But single T only if you are taking means Kelvin scale temperature is different, centigrade is different. If you want to convert centigrade scale into Kelvin scale, no, centigrade scale plus approximately 273 is equals to temperature in Kelvin scale you will get. So in this case you are taking the alpha as so temperature Kelvin comes in the denominator, the temperature difference it is. So Kelvin scale, centigrade scale same, 12 into 10 to the power of minus 6 per degree centigrade is also equal to 12 into 10 to the power of minus 6 per Kelvin equivalent, but Fahrenheit is not same. If you are taking the Fahrenheit conditions, 100 degrees centigrade equal to 100 degrees Fahrenheit is equals to 100 Kelvins divided with 100, what you get here is 1 degree centigrade is equals to 9 by degree Fahrenheit. So is coming in the denominator, so 1 by centigrade it is. 1 by centigrade means 1 by centigrade replaced with 9 by 5. 5 go to the numerator, 12, 5, 60 by 9. The result is 20 by 3, 10 to the power of minus 6 per degree Fahrenheit. But the centigrade if Kelvin is nothing but equal to same value, 12 into 10 to the power of minus 6 per Kelvins. Kelvin, centigrade same per if you are taking the temperature differences. Next, third question. Alpha linear expansion coefficient is given for the solids and the temperature change is 100 degrees centigrade is also equal to 100 degrees Kelvins. Find the percentage change in area. area. Areal expansion coefficient beta is equal to delta A by A, change in area by initial area into change in temperature. So delta A by A is nothing but equal to into 100 percentage change in beta into delta T into 100. This one do not depend, percentage changes do not depend on the physical dimensions. Even if you take this percentage in the length, if they ask you delta L by L equal to alpha into delta T into 100%, this is percentage not there means relative changes you have to take. Percentage change means into 100 you have to take. Into 100%. So percentage do not depend on the initial lengths, just alpha into delta T into 100%. Similarly for the linear areal expansion coefficient, delta A by A into 100 equal to beta into delta T into 100, do not depend on the areas. So but beta is given, alpha is not given. Beta and alpha relation is beta equal to 2 alpha. So what I get here is this beta replaced with 2 alpha, 2 into 10 to the power of minus 6 into delta T, change temperature is 100 degrees centigrade and into 100%. The result is 2 into 10 to the power of minus 2 percentage, you will get means 0.02 percentage. Next, similarly if you require a volume coefficient, for the volume coefficient gamma is equals to change in volume by initial volume into change in temperature, so you have to take. And one more important question repeatedly asked is, if you take the two different material rods, two different metals are taken, one is a copper, another one is a iron. The difference in length is delta L. What are the initial lengths you have to take so that after heating to any temperature for both, the change in temperature remains constant. The condition is initial length L1 for the first material copper into expansion coefficient alpha copper is supposed to be equal to, that means L1 alpha 1 is equals to L2 alpha 2. This is for the copper, these two for the iron. L1 L2 are the initial lengths only, and L2 minus L1 is nothing but equal to constant, remains constant, that is delta L we take. One more thing is, which one you have to take more length, which one you have to take less length is alpha. If it is more and less, this alpha is high means length should be less. Alpha L equal to constant means alpha copper is more than that of the iron, alpha brass more than that of iron, then that length which has alpha is high means its length should be less. Similarly, if you take the volume relations, if you take the containers and if you are heating the liquids, what happens here is, first container gets heated up and liquid gets heated up and expands. Due to the expansion of the container, the liquid level first falls. After that, liquid is heated and level increases. What we are seeing for the liquid is called as a expansion, is called as apparent expansion, not real ones. Because the expansion of the container we don't notice that will be very less, but the expansion of the solid liquid takes place afterwards. That will, because of that reason, expansion of the solid, the level is rise. What you are seeing is not the exact values. So to avoid the expansion of the container, to compensate that, what we have to take is, we take the liquid mercury in a glass. The gamma mercury is 7 times gamma glass. So volume expansions, if you take for solids length rods, L1 alpha 1 equal to L2 alpha 2. For the solids, if you have the equal volume expansions, the condition required is this L1 means volume you have to take. V1 gamma 1 is equals to V2 gamma 2 condition you have to take, so that the difference in the volumes always remains constant with the increase of temperature, so that the expansion of the container is neglected. You can get the real expansion of the liquids. So liquids have the volume expansion only, that two kind of expansions, real one and apparent one. Apparent real expansion, gamma real is nothing but equal to gamma apparent plus gamma solid. Gamma solid is 3 times alpha solid. These only problems related may be asked for the liquids, that we will discuss at the end. Next question is number 4. Brass sheets having the length and breadth, area is, length into breadth is 200 square centimeters at initial temperature 21 degrees centigrade. Find the new area at 100 degrees centigrade. When you heat the sheets, metal sheets or any rods, so what happens is the length increases. Why length increases? The molecules starts vibrating, the distance with the molecules increases. Due to that reason, all the metal expands on heating. Every dimension increases. If you take the plate with the holes, on heating it, the outer side, this area increases, the size of the holes increases, distance between the holes also increases, distance between the adjacent molecules increases, so every part increases, size of the hole also increases and plate also increases. If you take this cut hole and then you take out this circular portion outside, increase in temperature is same means whatever the hole size is increasing, the plate size also increases. Hole behaves as if it is a plate with the same expansion coefficient. More expansion coefficient, more increase in length, more increase in area, less expansion coefficient, less increase in length and increase in area and volumes. Same thing on cooling. Heating temperature increase means length increase. On cooling, by the same effect, temperature decreases means the length, area, volume decreases. More alpha, more increasing and more decreasing also on heating and cooling. Next, broadsheet initial area is given, you are asked to find out the final area. So this delta E is equals to A2 minus A1 by A1 is equals to beta into delta T. Equating for this A2 final area, A1 times 1 plus beta into delta T is the change in temperature you will get. Change in temperature is T2 minus T1. Delta T is T2 minus T1. T2 is 100 degrees centigrade, this is T2, and T1 is 0 degrees centigrade. So 100 minus 0 is 100 only. So delta T is 100. Beta is not given. You are given alpha. Beta means 2 times alpha you have to take. Means 36 to the power of minus 6 you will get on calculating. If the result is 200.72 square centimeters. Solids expansion is very less compared to liquids. Liquids expand 20 times more than that of the solids, whereas the gases on heating expand 200 times more than that of the solids and liquids. Gas expansion is very high compared to that of the solids and liquids. Next, this problem is related to the gases. For gases, we basically use the formula ideal gas equation. Ideal gas equation, ideal gases are the gases whose particle size is negligible and there is no molecular force of attraction for ideal gases. Because of that reason, the potential energy is 0 for ideal gases. And what they have is only kinetic energy. Kinetic energy is a measure of internal energy, which is depends on the temperature. More temperature, more internal energy, symbol we take it as a capital U, and more is the kinetic energy. So kinetic energy is directly related, proportional to internal energy and temperatures. Temperature increases means kinetic energy also increases. In these gas problems, we take the temperature in Kelvin scale, so you have to be careful with that. Internal energy is the total energy of the gas molecules inside, that is sum of the kinetic energy plus potential energy for real gases what we see in the daily life. But real gases behave as ideal gases at high temperatures. Real behaves as ideal gases at a high temperature. High temperatures and low pressures. Low pressure means less number of molecules. Pressure is proportional to number of moles or mass of the particles we can take. Less number of particles means less pressure. Pressure is exerted due to the force exerted by these particles on the walls of the container. More pressure exerted means more force they exerted means more pressure. Pressure is nothing but equal to force by area. Force is nothing but change in momentum. So more collisions with the walls, more is the pressure. That depends on the more number of molecules. Pressure is proportional to mass. And related to the ideal gas equation, PV equal to nRT. N is the number of moles, maybe sometimes given as the mu symbol. R is the universal gas constant, is constant for all the gases. Its value is 8.31 into 10, or sometimes given as 3 into joule per mole per kelvins. And P is the pressure. When they mention that standard temperature and pressure, at STP they mention. STP standard temperature and pressure means pressure is 1 atmosphere, value is 1.01325 into 10 to the power of 5 pascals. Temperature is 0 Kelvin, you have to take 273 kelvins. Plus 273 equal to 273 kelvins is the STP. Normal temperature pressure, NTP means temperature only changes, that is the room temperature. And pressure is the atmosphere pressure only, but temperature only is room temperature you need to consider. That is generally 27 degrees centigrade we use. Okay, next, volume of 1.5 mole of gas at STP is how much? According to the Avogadro's law, volume of any gas, 1 mole of any gas occupies the volume equal to 22.4 liters. But you have the now 1.5 moles. So this we are calculating is volume equal to nRT by P. For 1 mole if you have taken N equal to 1 mole if you have taken means 22.4 liters you will get, and 1.5 moles how much? Just take directly calculation here, multiply with the number of moles 1.5, the result is 33.6 liters. If they ask in cubic meters, 1 liter is 10 to the power of minus 3 cubic meters. This number of moles is nothing but also equal to mass by molecular weight or molar mass we call it. Molar mass or molecular weight. This also number of particles, if you require no number of particles, N is equals to number of moles into Avogadro's number. This is number of atoms is equals to number of moles by number of Avogadro's number, which is nothing but equal to mass by molar mass into Avogadro's number. If required, number of atoms or molecules if you want. Ne is Avogadro's number, 6.022 10 to the power of 23. Next, question number 36. Gas at 627 degrees centigrade. Centigrade means converted to Kelvin scale is cooled so that final pressure is 1/3 of the initial pressure. Volume is kept constant here. Final temperature is how much? Here ideal gas equation PV equal to nRT. This you need to modify according to the requirement. PV equal to nRT. N is equals to mass by molar mass. Also we can take if according to the requirement. If we require in masses equal to mass by molar mass into RT. Here in this case, if the P is you can also write this as PV by T or equal to N or equal to constant. N is the number of moles given gas closed container you are taking, means N is constant, R is however is constant. If temperature is also constant, called as isothermal process. If P is constant, called as isobaric process. If volume is constant, called as a isochoric process. Isobaric, isochoric, isothermal process. Adiabatic means temperature is not constant. So in this expression, what is told is volume is constant, that's told. V is constant, that means P by T equal to constant, remaining all constants. So P is proportional to T, or P by T equal to constant, means P1 by T1 is equals to P2 by T2 we have to take. But temperature is given in centigrade scale, converted into Kelvin scale by adding 2 plus 273 plus 273. So we want the final temperature T2 equal to P2 by P1 into T1. These problems are important. I am discussing only in terms of pressure and temperature. Similar problems are there in terms of the volume, temperature, you check up that. The result is T2 equal to P2 by P1 into T1, but T1 is centigrade scale, no, convert into Kelvin scale by adding plus 273. But P2 is given as P1 by 3, P1 cancels, 1/3 of 627 plus 273 is 900, 900 by 3 in Kelvin scale is 300 kelvins is the answer. Next, 47th question. Closed container with ideal gas V1 is 9 liters and pressure is 76 millimeters. This is 1 atmosphere pressure, normal atmosphere pressures is connected. Of mercury means mercury height of length equal to mercury column of length equal to 760 millimeters or 76 centimeters, exert the same pressure as the Earth's atmosphere on the Earth's surface at the sea level. If you require for water level, what you take is pressure equal to HDG formula. If it is for mercury, this is 1 atmosphere. If you are taking the mercury, H of the mercury, density of the mercury into G. Water, if you have taken height of the water, density of the water into G. If they ask the alcohol, etc., height of the alcohol, density of the alcohol into G. Same formula, equate it and you will get the expression required for the heights of the different liquids. For water, the corresponding pressure becomes equal to height. Pressure height is nothing but equal to 10 liters you will get. Height of water is 10 meters, approximately 10.33, nearly 10 meters of height to equal to 76 millimeters of mercury. It is first vessel of 9 liters is connected to the second vessel of evacuated. Evacuated means vacuum. Vacuum pressure is 0. That means P2 equal to 0. This is for vacuum. Vacuum pressure is 0. So always gases and fluids will flow from high pressure to low pressure irrespective of the other conditions. Find resultant pressure you have to find out. So they are connecting pipe negligible, capital tube you have to neglect this volume. So this volume plus this volume finally becomes our gas occupies both boxes. So what you have to take is total volume V1 plus V2. Temperature not mentioned means take it as a constant. Constant means we take it as a isothermal condition, T1 equal to T2, same temperatures. So PV equal to nRT, P1 by PV by T equal to constant. What is depends constant in this case is number of moles constant, N equal to N1 plus N2, and PV equal to nRT, N equal to PV by RT. Same thing for this P1 V1 by RT1. P2 V2 by RT2, but T1 is equals to T2, temperature is constant, this is equals to T1. So that will be cancelled in the expression. The result, this formula you need to remember. Final pressure is equals to P1 V1 plus P2 V2 by V1 plus V2. This is final resultant pressure. Common pressure 760 plus into 9 plus this pressure is 0 into 9 by 9 plus 9 is 18. So 9 by 18 is by 2, you will get the result is 380. Same units what is given in here that you have to take. This is 1 atmosphere by 2, half atmospheres. Next question number 49. Density of air at NTP is given as D1. And if pressure is increased to 3 times initial pressure, find the new density. More molecules, more pressure you can take. So density is equal to mass by volume. We have the gas equation PV equal to nRT. So volume we have to eliminate. Volume is nothing but equal to mass by density. Given gas, mass is also constant. So what you get the expression we have to remember is P1 by D1 is equals to P2 by D2. This relationship you find out the D2. D2 is equals to P2 by P1 into D1. P2 is 3 times P1, so 3 times D1, the result is 3.8. And we have the gas loss equation, gas loss. Volume is proportional to absolute temperature, pressure and constant. Not only pressure, you have to keep even the number of moles also constant. And P is proportional to T. This is a Charles law 2, also called as the Gay-Lussac's law. In this case, volume and number of moles equal to constant. And then we have this Boyle's law. Boyle's law is P is inversely proportional to V. Condition is that the remaining constant, means temperature is constant and number of moles is also constant. Or number of gas molecules is constant, or PV equal to constant. This is called as the Boyle's law. Boyle's law is P1 V1 is equals to P2 V2. Graphs also important for you. Here directly proportional means the volume temperature graph, pressure temperature graphs are the straight lines passing through origin, but P is inverse PV equal to constant means P1 V1 equal to P2 V2 or P is inversely proportional to V. The graph is a rectangular hyperbola you will get. And the temperature pressure graphs, what you take, if you take the absolute temperature, capital temperatures, the graph should pass through the origin. This is for ideal gases. This is the volume or pressure you take, anything. At this temperature 0 kelvins, capital T means 0 Kelvin scale, at 0 kelvins pressure is 0 and volume also 0. There is no gas existing, it is converted into the liquid into or solids. This is for ideal cases. But real gas, what happens is before reaching 0 Kelvin only, they will be liquefied, other gases, what we see in the daily life. So practically we cannot, or theoretically also we cannot reach through absolute 0, because for cooling purpose we take the help of the gas only. But here gases do not exist up to the temperature 0 Kelvin, so it's not possible to reach the absolute 0. That means 0 kelvins. And if you take the same graph in centigrade scale, then the graph will be centigrade scale. If you take the graph will be intersecting on the temperature scale to minus 273.15 degrees centigrade. Negative graph. This is the volume and pressures will become equal to 0 at this point. That is supposed to be taken as a 0 Kelvin for the Kelvin scales. Next question number 55. Percentage change in the volume is given as delta V by V 100%. The percentage is 0.2% given. Percentage means change in value by initial volume. Without 100 means it is a relative change in volumes. Percentage change in volume is delta V by V into 100 equal to 2% given for us. And they asked the temperature changed by 5 kelvins, increased by 5 kelvins. Increased by 5 kelvins, that T2 minus T1 is 5 kelvins. Change in temperature is 5 kelvins. Final temperature is T1 plus 5. And we are asked to find out T1 is how much. Pressure is constant they kept. Change in volume by initial volume. This V delta V itself is V2 minus V1. Increase in volume. Percentage plus means you take it as an increase in value. Minus means decrease in values. So here V2 minus V1 by V1 is equals to 2 by 2 percentage means 2 by 100. Percent means per 100 is equals to 0.02. But we have the Charles law. V1 by T1 equal to V2 by T2 when pressure is constant. So we take this relation as V2 by V1. Final by initial you have to take for percentage calculation. Denominator must be initial values. V2 by V1 equal to T2 by T1. And the increase in value means minus 1 you take both sides. So the result is V2 minus V1 by V1 equal to T2 minus T1 by T1. But V2 minus 1 by V1 is nothing but equal to this value we have. And T2 minus T1. T2 minus T1 is 5 kelvins here from this. So this 5 by T1, this is going to be 0.02. We want a T1. T1 is nothing but 5 by 0.02. This is going to be 500 by 2. This is 500 by 2, which is nothing but equal to 250 kelvins. We are taking already capital T. So 250 kelvins. If they want in centigrade scale, minus 273 I have to do in centigrade scales.